No, myself is Mohammad Shahabuddin. I am lecturer in electrical engineering department, Imperial University, Lucknow. So now we are going to discuss about the Thevenin's theorem. Thevenin theorem states that for the DC network, in any two-port linear network, current through or the voltage drop in any branch can be calculated by drawing an equivalent circuit which will be having a voltage source VTH and in series a resistance RTH. So this is suppose this is the network N and this is load resistance RL. So this network N is the equivalent circuit of this one, okay, which will be having a voltage source VTH and in series a resistance RTH, and this is the load resistance and IL is the load current. So IL will be equal to, that is load current will be equal to VTH, Thevenin's voltage upon Thevenin's resistance plus load resistance. Okay. In order to understand in better way, now we are taking some example. Okay. Suppose we have a network like this. Okay. Have a 9-volt source and 2 ohm resistance here, 2 ohm resistance here, 2 ohm resistance here, and a load resistance of 4 ohm here. Now we will have to find out the current, load current IL in this branch. So first of all, we will have to draw the equivalence, Thevenin's equivalent circuit of this network. So Thevenin's equivalent network of this circuit will be here, will VTH, RTH and RL is equal to 4 ohm, where VTH is the open circuit voltage when load resistance is removed, and RTH is the Thevenin's equivalent resistance looking into the network when all sources are replaced by their internal resistances. Okay. So now first of all, we will have to find out the VTH, that is open circuit voltage, Thevenin's voltage. So now we will redraw the this network. Okay. Okay. So this network will be become like this here. Okay. So it will, now the load resistance is removed. So the drop across this resistance will be equal to the VTH. So now we will redraw this circuit. So it will become like this: 9-volt source here, 2 ohm resistance here, 2 ohm will become in series, because no current will flow in this branch because here is open circuit. So all current will confine through this branch. Okay. So now further this circuit can be redrawn in this way. There will be 9-volt source and 4 ohm resistance, because this resistance will become in series. The equivalent of this will be 4 ohm. So this current I will be equal to V upon R. So V is 9 volt and R is 4 ohm. So 9 by 4 ampere I. So drop across this resistance will be V2 is equal to VTH is equal to 9 by 4 into 2. So it will become 9 by 2 volt. So VTH is equal to 9 by 2 volt. It is calculated. Now we will have to find out the value of RTH. Okay. So we will draw this network here. This source will be short circuited and this resistance will be here, this way. So RTH will be looking into the network. So RTH, when we will calculate the RTH, this resistance and this resistance will become in parallel in series with this resistance. So RTH will be equal to 2 into 2 upon 2 plus 2 plus 2. So it will become 4 by 4 plus 2, it will equal to 3 ohm. So RTH will be equal to 3 ohm. So now we will have to find out the value of load current IL. So IL is equal to VTH upon RTH plus RL. So VTH is 9 by 2, it is already calculated here, and RTH is 3 ohm, it is already calculated here. So 9 by 2 upon 3 plus 4, value of load distance is 4 ohm, so 3 plus 4. So it will become 9 by 2 into 1 by 7, so it will become, IL will become 9 by 14 ampere. So load current is 9 by 14 ampere. This will be the answer. In this way, we can simplify any network through the Thevenin's theorem. Thank you.